Hi, everybody. Welcome to the June New York JavaSIG meeting. Thanks for showing up. We have 3 speakers tonight. But before we get started, I want to thank Bank of New York Mellon. Thank you for hosting us. So thank you, Bank of New York. Also, I want to thank Rajiv for sponsoring the pizza and Grid Gain for sponsoring the pizza. Thank you, Grid Gain, Rajiv. And we have some giveaways tonight besides the IntelliJ licenses, which I think everybody has an IntelliJ license now. So instead of a giveaway, we're going to do a takeaway. Whoever wins, we remove your license. I'm only joking. And we also have some books from O'Reilly. So it seems like people still want physical books, we're finding out. So that's cool. So normally we start off with some questions about, open questions about Java from the audience. But I think because we have 3 speakers tonight, we're just going to jump in right away. Also, thanks to Dave Wong for being our rep for Bank of New York Mellon. He's the gentleman that was pointing everybody in the right direction. So thanks, Dave. I know you're not here, but thank you. So let me turn everything over to Rajiv, who will give a talk on real-time data with Grid Gain.
Thank you. Hi, my name is Rajiv Shah. I'm working as a principal architect for a Grid Gain. And today I'm going to talk about how customers are using Grid Gain's real-time transactional and data analytics platform. What I'll do is that I'll focus on a technical, and as Frank mentioned, we have a limited time. So it would be, I'll just give a presentation, and afterwards, if anybody has a question, I'm just here. Feel free to ask me any question. And also, I have a data sheets here. I circulated to some of the people, but remaining people, feel free to have it from here. So here is the high-level architecture overview of our platform. So as you can see that normally, if any customers or any developer wants to develop the application, they develop a transactional application using Java, C++, .NET, Python, Scala. They develop the reporting app using different BI tools such as Tableau, microservices, Sisense, Power BI. Or if they want to develop AI ML, they use Apache Spark or TensorFlow or Python or different programming language. And for the persistent layer, they use different flavor of RDBMS such as Oracle, DB2, SQL Server, and others. They use different flavor of NoSQL such as DynamoDB, MongoDB, and others. Or some of them are still using mainframe, and nowadays they also use data warehouse and data lake. So that will allow them to fulfill the functional needs. But when it comes to the non-functional needs, such as low latency, high concurrency, scalability, they try to fine-tune their business logic, or try to normalize or denormalize table, or try to add indexes. That take them a little bit, but still end of the day, all traditional database are persistent based, means there is a file IO, and also it's normally located in most of the enterprise in different subnets. So there is a network IO. So that's where they place our product co-located with application, and it helps them to get the best performance out of that. Here is the overview of how our platform works. So if you see in the center, that's our product. Our product has a many feature, but this is just highlights of our feature, such as we are fully ACID compliant. That's why financial institute, trading application, airline, e-commerce, and others are using our product. We are one of the very few products who has a support of in-memory, row-based storage, and columnar storage. And why it's important? So whenever someone wants to develop the transactional application, normally they try to store in a row-based data because that's where they get best right performance. But when they want to have a read-based application, that's where they need a columnar storage. That will give them a best result. So what we have done is that as part of our product, we provide out-of-box storage in a row-based and columnar format. So based on your need, you just put the appropriate annotation, and it will automatically store in appropriate storage. And some customer may have a requirement because they may not know that what's their load. They can store in a both. There will be additional infrastructure requirement, but still without writing duplicate code. It still store the data and they can get best of both breed. Our product has been also used for the co-located compute logic. What it means is that whenever, let's say, take example, BNB Malon, right? At end of the day, when they receive the trades, and during the day, they have received the fixed drop copy. Now, at end of the day, they have a very limited time. In that time frame, they need to go through the file they have received from their clearing firm and the trade they have received during the day and need to do the reconciliation. Now, what have observed is that when customer try to use the traditional database, they have to do lot of round trip to the underlying database, and they may not need to fulfill or complete that cycle in timely manner. So whereas here, now they have all their data in a RAM and it's a distributed data grid, it means that it scales vertically and horizontally that allow them to run the compute logic in memory co-located with that data. Our product is a memory centric and it's basically RAM first. It means that by default, it stores the data in a RAM. But when we have a many customer, they say, hey, we want to accelerate our data lake. In that scenario, they may not want to load all their data in a RAM because that could be very high infrastructure cost. So in that scenario, when they create the table, they can put appropriate definition over there. So they can have a like only 90 days worth of data in a RAM and then remaining 6 years and 3/4 of data in our persistent storage. So still it's perform much faster than the database. And for them, they still run single query and our product takes care of getting the data from appropriate sources. Now, this is about our product. We have many more features, but in 10 minutes, we cannot go everywhere. So how to use it? Now we talk about how to get the data. Now how to use it and what are the common use cases. We have customers who are using for the enterprise acceleration, such as the transaction and analytics application, compute processing, such as Apache Spark and the compliance and many more applications. We also provide the platform and we have a full integration with Apache Spark and other AI ML. So it allows them to run the AI ML co-located with their data to get the best of both breed. And also customers use our product for the hybrid transactional and analytics. So if I give a simple example, when customers are using Apache Spark, they can do the ETL, but after processing the data, when you turn off your Spark executor, you lose your data frame and data set. And if you try to store that in a HDFS or other data storage, then still from your transactional application, you need to bring that data back. So there is a latency between persisting to storage and bring it to back. Versus from our product, we have extended the Apache Spark and from data frame and data set, it allows you to store directly to in-memory grid. So that way your transactional application has that data available. And that allow customer to run many more iteration of their AI ML training models. Now, what are the different way to expose it? So again, our product have a many different client-side API. Typically, when you use databases, they just have a SQL interface to fetch the data. Whereas from our product, customer can use either standard SQL interface, but also in parallel to that, it has a native Java API. So if you are writing Java API without going through marshalling, demarshalling, or SQL conversation, you just make a call and you get the Java object. Same way, we have a native API for .NET, C++, Python, and others. So that allow you to run your application much faster without going through the SQL interface. And what are the different reasons, such as non-functional requirement, where we provide the benefit? First one is a scalability. What it means is that, let's say when you create Oracle or SQL Server cluster, still there is a certain amount of resources you define. Whereas our product is an in-memory distributed grid. So take an example, yesterday there was a FAD meeting. And during that FAD meeting, there was a volume spike in a 3-fold. So instead of pre-allocating your infrastructure, just like an hour before, you can add additional node, add few more partition to support additional volume without degrading your SLA. We provide high availability because our product is a RAM based. It means that processes can go down. So what our product do is that they support in-memory backup, and normally backup partitions are running in a different machine and different processes. So if any of your processes or even machine goes down, still your grid is intact and your customers are serving the request without any downtime or compromising with the SLA. We provide interoperability because you could have an application, Java application writing the data and then C++ application reading the data, whereas without worrying about COM bridge or any other JNI operation to convert your data or writing and intercommunication between different or heterogeneous programming languages. Security. We have a full integration with LDAP, Azure Active Directory, and many more authentication and authorization systems. Durability. As a part of our product, we have ACID compliance and we provide our own persistence layer. So that allows the durability of data in case your machine goes down. And observability. So when you develop typical Java application, there is no way to have a monitoring tool or others because then you need to develop. Whereas as part of our product, we have a SaaS-based solution to provide the observability. And now, as we are supporting heterogeneous databases, customer can store their data in a key value, relational database, columnar format, and many other formats. Our product is running on an on-premise, on bare metal and VM. It's been running on many different clouds, on a regular EC2 instance, Docker images, and also Kubernetes. And these are the two common use cases we have seen. One is as a cache, and second is a data hub. So cache, you got it. In a data hub, what customers do is that they have a heterogeneous and multiple data sources. Now, if you put their virtualization layer, then your slowest database will be your bottleneck. Versus here, using our CDC integration and bidirectional communication with underlying data sources, they fed the data from different data sources, load the data in a new data format, and then your client application just need to interact with our integration layer or digital integration hub without going through the databases. So I think that's more or less highlights because we have limited time. But if you have a question, you can have my phone number or I will be here. Feel free to ask me any question. Thank you.
Do we have time for one question? Does anybody have a question for Rajiv? Okay. Rajiv, what was the open source name for
Apache Ignite. So when I will circulate this one, there is a one particular slide where it showcases that what's in a community edition. So all these features, most of them are there. And also it has a differentiation between open source versus non-open source. So I'll circulate that PDF to you and you can circulate it.
So it's Apache Ignite.
That's our open source version and it's been used across the world by many companies.
Whenever you're ready. You need one of those. Okay, that's good if I get here.
All right. So hello, my name is Vlad Zakharov, and by way of very quick introduction, I've been programming in Java for over 20 years, mostly in financial services firms. I was a member of the JSR 335 that delivered Lambda expressions for Java language, and I served a few years. You're welcome. It was a long, hard road, but we got there. And I served for a few years on the Java community process executive committee. But anyway, moving on with the talk. So this talk will talk about data frames, specifically Java data frames. So it's not like Python or other languages should have all the fun. And we specifically talk about what data frames are good for in the context of data-oriented programming. So before we talk about data frames proper, let's define that data-oriented programming. It's a term that's been heard around pretty often lately. Sorry, and this is something that we had presentations, folks presented and published blogs. So, oh,
Can you see the, just, no, just, don't say anything. It hasn't quit, it looks good.
oh, okay,
I don't know why.
okay. Sorry. So I'm not going to go too deep into data-oriented programming, certainly not going to do justice to this topic because we don't really have time for that. But also there are really good materials like the links you see on the slide that I highly recommend folks who are maybe new to the topic just look at it. And they certainly go much deeper into the what's, the why's, and the how's of data-oriented programming. But just to define it, here is a quote from Brian Getz, the lead architect for the Java language. Data-oriented programming encourages us to model data as immutable data and keep the code that embodies the business logic of how we act on the data separately. So to kind of better understand data-oriented programming, maybe it would be helpful to compare it with another paradigm, object-oriented programming. And the differences are in how, well, state and behavior are being defined and managed between these paradigms. So with data-oriented programming, you just model everything as data, where data entities are basically collections of properties, and then you expose them to whoever needs to do whatever with that data. And obviously, because the data is shared, you want to keep it immutable, otherwise there will be chaos. Whereas for object-oriented approach, you want to protect your state, you want to protect implementation details, and you basically talk to objects, but thanks to things like polymorphism, you may not necessarily know what type or what actual implementation of a method is being invoked in response to your message. So we're not going to go into these details. Like I said, I recommend looking at the articles I shared, but we'll cover some of these points in the subsequent slides. So to make it a little bit more concrete, let's look at a particular business domain. And this is also the domain we'll be using later when we get to code examples. So in this case, our domain is an online donut shop. So we have donuts that are listed on the menu. So it's a donut kind, then there is price and maybe discount price for high volume orders. And the key entities are also customers with their name and address, and orders, which is basically a customer purchasing quantity of donuts to be delivered on a given date. To keep things simple for the purpose of this exercise, a customer can only order one kind of a donut. So this diagram on the object-oriented side is kind of a so-called donut diagram, is meant to show how you can only interact with the boundary of the object. So you see this boundary, and these are the messages that the object understands. And there may be state, or maybe there is no state, because when you talk to an object, you really don't know where the data is coming from. The data could be computed. It could be coming from dependent objects, or from some objects this object collaborates with, or whatever. Whereas if you look at the data-oriented approach, it's basically the opposite, right? You break everything open, you define your state. Here is a collection of properties and tables, which could be for example, lists of Java records. And like I said earlier, these properties are exposed to whoever wants to do whatever with it. So people just write functions to operate on this data. So for example, this is a function that finds 3 best-selling donuts based on the order quantity using Java Stream API, collectors, and records, the records that you see on the slide. So we're already doing data-oriented programming with the existing tools in Java with streams and records. And in fact, recent versions of Java have been adding more and more features to support data-oriented programming. You see some of them on the slide. We're not going to cover them. Again, hopefully folks are familiar with these recent developments, and some of them not so recent. However, these features don't come without any cost, right? And I'll just mention a couple of concerns. Let's say one is memory overhead. And again, it really depends on the volumes you're dealing with. So if you deal with millions or billions of objects, the overhead of having a record would really add up, right? So for example, for our records here, customer donut order, you see the overhead of just having one instance. It's on the slide, 12 or 16 bytes. And like I said, if your business is successful and you deal with like billions of donuts, then this becomes material. Stream code readability is not always amazing. Like if you look at this code, it's certainly better than if we were writing nested for loops and if statements, but it still, I feel, could be made more expressive, more concise. And yeah, let's not even talk about maps. So let's see what data frame adds to the mix. So first of all, what is a data frame? It's pretty simple. It's a data structure that is a tabular data set, meaning it's made up of columns of different types, like a database table, and it can be manipulated programmatically. So what's so great about data frames? Well, data frames make it very easy manipulate data in an agile and efficient manner. And it offers benefits of developer efficiency and potentially end user efficiency. And we'll look at examples what we mean by that. Also, data frames leverage efficiency of underlying collection frameworks they can be based on, and they can support other optimization techniques like instance pooling. And this is something that's done internal to the framework without any effort from the developer. As opposed to, for example, if you're dealing with records and you want to do object pooling, you have to kind of build something yourself. And of course, data frames, we're going to look at examples of frameworks that are used in real-world scenarios, Java data frames, I mean, for data transformation, data enrichment, data quality, reconciliation, and other use cases.
Let's move on to the examples and look at some code. For our first example, we will look at the 1 billion row challenge. The 1 billion row challenge was organized by Gunnar Morling and ran through January of 2024. And the purpose of the challenge was an exploration of how quickly 1 billion rows from a text file can be aggregated with Java. Quoting from Gunnar's blog post announcing the challenge. Your mission is deceptively simple. Write a Java program for retrieving temperature measurement values from a text file and calculating the minimum, mean, and maximum temperature per weather station. There is just one caveat, the file has 1 billion rows. You can find details of the challenge, the scripts to generate test data, and the submissions at these links here on the slide. And if you're not familiar with the challenge, I highly recommend checking it out. We will be looking at this not because we're hoping to create a competitive solution, but rather because 1 billion row challenge is a classic data-oriented programming problem, and so we will use it to illustrate how data frames work really well for it. But first, let's describe what we mean by well. So looking at the existing solutions first, the times produced by the winning entries into 1 billion row challenge are nothing short of amazing. The entries placed first, second, and third completed the challenge in the reference environment in about 1.5 seconds. And looking at the 1 billion row challenge repo, you will likely notice that most top submissions have a few things in common. Each one of them is many hundreds of lines of well-formatted, well-factored, and sometimes well-commented code. And it's not immediately clear how the algorithms work, just due to the sheer complexity of that code. And also, it's not always easy to tell just by looking at the code what the code does functionally. I mean, you obviously know what it does. It solves 1 billion row challenge. But had you not known that, you would have had trouble figuring it out right away just by looking at the code. And this makes sense in the context of the challenge. By itself doesn't make the solutions bad code. Achieving absolute peak performance will require these kinds of quote-unquote sacrifices. It requires advanced Java optimization techniques, low-level APIs, vector API, the latest language features, JVM features, and some dark magic. And it requires a good amount of developers' time spent both writing and reading the code. So what if we turned it around, so to speak? What if the things like code readability, maintainability, developer time, developer efficiency matter to us more than peak performance? What if the cycle spent developing, understanding, and maintaining this code by humans mattered more than achieving the absolute minimum of CPU cycles? What if we could deliver a working solution very quickly and then optimize it if and when needed? Well, enter a data frame. As I go through the code, I will show the output of each step using the story example. And this is the same file format as the one used for the 1 billion row challenge. Obviously, the size is much smaller, but any code here we're going to look at will work with files with 1 billion rows as well. And you can try it later. We're breaking down the solution into 3 simple steps. Load data from the file, then we process data, that is, do our grouping, aggregation, and sorting of the results, and then we output the result to the console. And we're going to look at solutions implemented with 2 different data frame libraries, data frame EC and TableSaw. Full disclosure, I'm the creator and developer of data frame EC, and I picked TableSaw for comparison because it seems to be widely used and also appears to be actively supported. So let's load the file into a data frame. First, we get the file location, and then we describe the file layout using an instance of the schema class. The file has 2 columns, which we declare here, weather station of type string and temperature of type float. The file has semicolon as a separator, and there is no header line, so we specify all that here. And then we create a dataset object that points to the location, physical location of the file described by the schema, and we'll load it as a data frame, and here it is in memory, parsed and loaded. Also, data frame internally does some optimization things like object pooling, but you as a developer don't need to worry about that. Grouping data and computing aggregate value is actually very easy with the data frame. And conceptually, it very much resembles a SQL select statement with a group by clause. So for data frame EC, you have aggregate by method, which takes 2 parameters. The first one is a list of aggregation functions, and each function here takes as parameters name of the column to aggregate and the name of the result column. And we also specify the list of columns to group by, and in this case, there is just 1 station. Now, you may be wondering what this immutable business is. We will talk more about it in a bit, but for now, just to clarify, avoid any confusion, data frame EC is based on the Eclipse Collections framework, which is a complete replacement for the JDK Collections framework. And in addition to re-implementing all the JDK collection APIs, Eclipse Collections features additional collection types, including a full complement of immutable types. So in this case, it's just a factory method that creates an instance of a list. So once we're done aggregating, we get this first result, the data frame at the top of the slide, which is a summary data frame. And then we sort it by the list of columns. In this case, again, there is just one station, and we get this result as a data frame. And to output the results, we're going to use an internal iterator for each. It executes the lambda that we pass in as a parameter, and the lambda takes one parameter, the current row, or you could think of it as a cursor. And in this case, we simply call the printf function to output column values for each row. Now let's see how we can execute the same steps using a different data frame library, TableSaw. And unsurprisingly, you will find that the solution looks very similar to what you saw with the data frame EC. The data frame type in TableSaw is called table. We describe the file schema in a very similar way. We read the file into the variable called measurements of type table. And really the only difference is that you can specify column names in the schema, so we name the columns after the data has been loaded. Aggregation with group by, again, it looks very much the same as data frame EC, except you cannot specify column names for aggregation targets. They will be generated for you. And then we call sort, and we basically get the same result, except column names are different. Output, again, follows exact same pattern for each internal iterator, which executes a lambda passing in current row as a parameter. So looking at this, does it mean that all the APIs are very much the same for these frameworks? No, not really, and we'll soon see examples where there are differences in design and implementation choices that result in very different code to solve the same problem.
So just a quick detour to talk about data frame EC and some of the design choices behind it. So like I mentioned, it's based on the Eclipse collection framework, thus the EC in the name. It's memory efficient, again, mostly thanks to underlying Eclipse collections, which has memory efficient implementations of various collection types, including full support for all primitive types. It does expose Eclipse collection types in its API, as you saw. So another distinction is expression DSL that's used for things like computed columns, filters, etc. You'll see the difference. It uses external expression DSL versus other frameworks may be using internal DSL, which is Java code, and we'll see what it means to you as a developer. And another thing that really matters in like kind of real life scenarios where data can be quite nasty is dealing with nulls. There is a lot of flexibility when it comes to how you process nulls. So let's look at some interesting or more interesting examples with more complex examples with donut store. So this is the domain, donut domain that we saw before. We have three types of entities: customers, menu of donuts, and orders, all represented as a collection of properties, and these properties are columns in their respective data frames. So we have three data frames named customers, menu, and orders. And we'll look at four use cases to see how we can implement it with data frames. List donuts in popularity order, so based on the sale quantity. Priority orders for tomorrow, so we will do some filtering, and priority orders are defined as large orders where quantity is greater than or equals 12, or random choice orders for Bob, so we like Bob and want to treat his orders as priority. We want to calculate total spend per customer, so basically two columns, customer and how much money they spent on donuts, and donut count per customer per day will let us see how we do pivot functionality with data frames. So listing donuts in popularity order, I'm actually not going to spend much time on it because it's very similar to what we saw with 1 billion row challenge. The aggregation is exactly the same. We add up donut quantity by donut. The difference is sorting. So here we sort by 2 columns, and we sort by descending order for quantity because we want top-selling donuts to show up first. And then we sort by donut if there are donuts with the same quantity values, we want them to show up in consistent order. And then because we only care about donuts and not the quantities, we call keep columns method on data frame, which drops all the columns except the ones we ask it to keep. Table saw, again, looks, works, feels very much the same. There are some differences in method names. There is different way of specifying sort direction. So you put minus sign in front of the column name. And yeah, otherwise we have same functionality and produce same result. Now, this is where it gets interesting. So priority orders for tomorrow, as you recall, these are orders that are either large, greater than or equal to 12 donuts, or the customer is Bob. And for data frame EC, we have a select method, which basically takes effectively a query criteria, where close. And this is a good example of an internal DSL, right? So you look at this. This is the first time you're seeing this language. You're not familiar with the grammar, but I would suspect strongly you can look at it and you can understand exactly what's happening here, right? And it takes you no time to parse it. Now, if you disagree, please argue. All right. Now, if we look at how table saw does it with internal DSL, you have to write this expression using Java and method calls and static methods. So again, conceptually, the where method is the same as select method in data frame EC, but the code looks a bit more verbose and just a bit harder to parse, and probably harder to write if you look at it. You need to know like all these methods and how to find them and assemble these expressions. You do get the benefit, of course, of this being Java, and so if you have a syntax error, you don't have to wait to run a test. You will get a red squiggly from your IDE. So there is that. Now, more interesting even is total spend per customer. So there are 3 steps we need to take. We need to calculate the dollar amount of each. Sorry, question? Sure.
Well, I want to do this right. Hey, here we go.
You say that we can catch errors at compile time.
I say you will catch errors at like
What if,
typing time.
What if delivery date is misspelled or?
Yes, that's an excellent point. Yeah, hopefully that got recorded.
Yes.
Yes. So it yeah. So yeah, write tests. So yeah, calculate dollar amounts of each order. Back to the next use case. We need to know, to do that, we need to know price of each donut. So to do that, again, basically thinking conceptually, how would we do it in the relational world? Well, we're joining data set of donuts to orders. So now we can access donut price for each order. Then we use this donut pricing formula, which is regular price times quantity for quantities less than a dozen. Otherwise, it's discount price times quantity. And then we do our usual group by and add up and sort. So joining, sorry, yeah. Frank is making threatening gestures. I'm good. So joining is pretty straightforward. You start with the data frame you want to join to, and I'm showing side-by-side data frame EC and table. So again, basic operations look very similar. You specify the name of the join column, in this case, donut, and data frame EC lets you select which columns you want to bring from the data frame you join to. And once you're done with the join, you end up with this data frame you see below, which now has columns for price and discount price. Now we want to calculate order price, so we want to add a computed column to that data frame with the order price that basically implements the order price formula. And for data frame EC with external DSL, it's very straightforward. Again, you have an add column method which can take an expression, and you can look at this expression. You can immediately understand what's going on there, and yeah, you don't need to specify the type of the column because the type of the column is inferred from the type of the expression. Everything is strongly typed. If you try to do things where types are incompatible, you'll get an error message to that effect when you run your tests or your code. With table SO and with internal DSL, that gets a bit trickier. So you create a column of type double column, which then defines a set of operations that can be performed on that column. We also create a variable quantity just to make the code more concise. We store quantity column and variable quantity. And then we use this declarative approach to set values for different predicates on the order price column. So it's not super cryptic. You can absolutely read it and figure out what's going on, but it's a lot of text for a person to parse to express this simple logic. Another way to do it with table SO is to do it more in the imperative way, where you use for each iterator and you calculate values and append them to this order price column, but declarative approach is better. Aggregation and sorting, we're familiar with it, so I'm not going to spend much time on it, but here we get our results, customer and their spend per customer. The last use case is donut count per customer per day, and this is where we see pivot table functionality. And again, it's really easy to do pivot with data frames. So side by side, data frame EC and table SO look very similar. There are two distinctions to call out. One is you see that data frame EC takes lists as parameters, so it supports multiple group bys for a pivot table and multiple aggregation values, which is basically how Excel pivot table works. Table SO only supports one of each, but that works fine for this use case. The other difference is when there are no values, table SO sum function returns nulls, or what they call missing values, whereas data frame EC will return 0. But again, null handling is an exciting separate kind of topic to talk about. And yeah, one thing to mention, to keep in mind when talking about differences between internal and external DSL is that sometimes you may have a requirement or a need for the business user, for the end user, to own and manage the business logic, things like data quality criteria or data enrichment rules or data validation rules or reconciliation rules. And in the case of internal DSL, well, you're not going to give them an IDE and have them write Java code and check it into your repository, so it gets tricky. What you want probably to do is to have some application with a front end where they can type these expressions and store it in some configuration or whatever, and that's much easier to do with an external DSL. All right, the last slide. So if you haven't done so, take a look at Java data frames, play with them. They may be, depending again on types of problems you have to solve, may be a useful addition to your data manipulation toolkit. Make a lot of data operations easy, easy to write, easy to read, and kind of three types of problems, three types of domains where data frames work well. Ad hoc manipulation of tabular data, so you want to play with the data, want to analyze, understand the data better. You might want to load it in Excel. Well, if you use data frame, when you're done with this, you have code that you can embed in your application right away. Would be harder to do if all your logic is in Excel. Programmatically transforming, querying, analyzing data. So yeah, maybe you don't need that Spark cluster after all. Data frames can be very efficient dealing with large volumes of data. You may be surprised how much data you can process just on commodity hardware with pure Java frameworks. And then your classic data science use cases, notebooks, visualization, and so on. Not all frameworks supported, but some do. So the talk and the sources as tests and data setup, it's all in this first GitHub repo. The next three links are links to data frame libraries. Two of them we covered. The third one is also well-supported library that's used in production, dflib. So check them out, have fun, and thank you. And if there are any questions, I'll stick around. So, oh, there.
With something like R, you can directly do your calculations and generate a graph, for example.
Right.
So how do you generate graphs and pie charts? And
so if that's your use case, and it's not everybody's use case, right? Because there are kind of data science use cases like what you're talking about, and then there are use cases that is more like accounting department needs to reconcile their tax tables. But for that, specifically TableSaw and dflib, so dflib integrates with Jupyter Notebooks, if I'm not mistaken, and TableSaw has visualization features as well.
I have a question about the internals of data frames. How do you store the data in data frame? Is columnar row-based storage? And what happens if I slice or build some views on this data frame? For instance, in Pandas, it's column storage, and I can easily slice and dice data frame. If I need some rows or columns, it's pretty easy operations, and this operation doesn't consume a lot of memory because you're working with view, with presentation, not with the copy of data frame. If you need to create a copy data frame, then you call method copy to get a pure copy of data frame. But in most cases, Pandas, they try to save a memory for you, and all this stuff is just presentation of the original data frame. What's with data frame EC?
Right. So these three data frame EC included, they're all columnar stores using either bespoke implementation of data structures like efficient lists, more efficient than native Java lists, or in case of data frame EC, it uses Eclipse collections implementation of again basic data structures like lists, bitmaps for its column data. And again, I can't speak for all the different scenarios, but yeah, there are certainly scenarios where, let's say, I don't know, if you sort a data frame, it's not going to physically rearrange things, right? It's just a view on top of the data frame. So filter
data frame, and I start working with filtered data frame. Will I work with presentations, some kind of presentation of this?
So with data frame EC, you will have a copy So yeah, Yeah.
Memory.
and again, test. Test and see if it matters in your use case, because objects are pooled. Again, the data structures are efficient. But depending on the scenario. Okay.
Thanks again, Brad.
Thank you.
Mike? Actually, while Mike is setting up, I promised that I'd tell you about an interesting thing that I found out with ChatGPT. So, there's this new model, ChatGPT 4.0. So it understands images. So I had this really cool thing. So I had a PDF that was in English, and I dragged it into the web app, and I said, translate it to Italian. And it was like perfect Italian. It's like, I was shocked. So it did OCR and then translation. So it was pretty mind blowing. So if you want to try that when you go back home on your desktop or even on the mobile, the ChatGPT app does not work on an Intel Mac. So it doesn't work on my home Mac. Only works on with their hardware. But if you use the web app, just drag a PDF, say translate to another language, and it's just mind blowing, and it's accurate because I've checked it with friends that can speak Italian, and it's like perfectly, it's mind blowing. Cool. Who's the? Yeah. There you go. Yes. There you go. Yeah. Okay. Oh, there. This one's not much. Okay. Oh, it's a Zoom. Yeah. Hmm.
All right. Okay. So welcome, everybody. Thanks for coming out and spending the evening with us. This is the first time I've actually presented here at the New York JavaSIG. So, yeah. But yeah, no, thank you. This is great. So this is Jakarta EE 11, going beyond the era of Java EE. And this was inspired by a blog post a little over a year ago by Steve Millage, the CEO at Payara. And in there, he said, well, from the initial lift and shift to the new namespace change in Jakarta EE 9 to the simplification work done in Jakarta EE 10, a lot of effort has gone into making Jakarta EE a solid basis for open source developers to build upon. And I wanted to mention here the initial lift and shift refers to Java EE 8 to Jakarta EE 8. And then he goes on to say, with that done, there's now the opportunity to start taking Jakarta EE beyond the Java EE era. With Java 21, and at the time he wrote this was on the horizon, there's now the opportunity to make sure Jakarta EE is always leveraging the latest and greatest capabilities of the new Java version, build new specifications, I have that underlined for a reason, and further unify and simplify the platform. So, hi, my name is Mike. I'm a Java champion. I'm the lead Java Q news editor at InfoQ, co-director at the Garden State Java user group. Yay. Yay. Back. Come on, Barry. So Barry serves in two roles. He does the AV here and does the AV by us too. And also contract developer advocate and tech writer for Payara. So I'm also on the leadership council for the Jakarta EE ambassadors and a committer on the Jakarta NoSQL and Jakarta data specifications. And by the way, I retired from Exxon just over a year ago after 33.5 years of service. So something I'm glad I was able to do. I highly recommend it for everybody, by the way. So for the next 3 hours, we're going to go over all this. Oh, no. What time do you want me to finish? So yeah, so the objectives here, when I'm going to quickly go through this, the evolution of Java EE and Jakarta EE, the profiles, what's new coming in Jakarta EE 11, the updated specs. We're going to just highlight a couple. And this presentation has all 16 that are updated. And then highlighted specs with demos. So this slide deck is on my website. You can grab that at your convenience. So quick poll, who's a Jakarta EE expert? What? Oh my God. All right, who's built an application using Jakarta EE? All right, beauty. 2. I'm familiar with Jakarta EE, but haven't used it. Okay. And I've heard some things about Jakarta EE, good, bad, or indifferent. All right. And then how many people here say, what the heck is Jakarta EE? Oh my goodness. Wow, we got one person there. All right, great. Thank you. All right, so quickly, this is a whole evolution going back to 1998, which is the Java Professional Edition. And this is before the days of the JCP, or the Java Community Process. And then we go on, Java or J2 EE, as it was called back then, in 1999, and then September of 2001, and so on. And then the name change started to Java EE instead of J2 SE, and they called it Java SE or Java EE 5. And then we got 6, 7, all right, and then 8 finally. If you look, there was a 4-year gap, more than a 4-year gap between the two. And this really created a somewhat of a ruckus in the Java community as far as Oracle dragging their feet on this. It triggered initiatives like the Java EE Guardians, which is now the Jakarta EE Ambassadors, and then also the microprofile initiative. We'll talk about that quickly. And then when Oracle donated Java EE to the Eclipse Foundation, it was open sourced, and then because of branding, the name had to change, and there was a whole community vote that came up with Jakarta. So Jakarta EE is essentially Java EE, except it's open source. 8, that is. And then 9 had some changes with the big name change or namespace change. And then 10 came out in 2022. And then 11 is planned to be out next month sometime. All right, so we took care of that. It's kind of early for questions, but anybody not know who that is? All right, here are the profiles. All right, so you have the platform, the web profile, and the core profile. Now, what the heck are those? All right, so the platform itself is a standard platform for hosting all of the Jakarta EE applications. Now, by that, if you actually go to the specification page and you count them, there are 42. However, only 30 of them are part of the platform. Some of them, I think, were evolved from the old Java EE and not maintained anymore, those kinds of things. All right. And then, so there's the list. Now, you notice here, this one in orange is brand new. It is Jakarta Data, and 1.0 was just released a week or 2 ago, and it will be part of the platform. And you can see all those specifications in blue that are getting updated. The web profile is a subset of the platform, but it's for web technologies, essentially. And then you see those 16 or so, a little more than that, I guess, that are in there. And you see Jakarta Data is part of that as well. And then last but not least is the core profile. It's basically targeting smaller runtimes, especially for microservices. And it was introduced in Jakarta EE 10, so it's not even 2 years old yet. All right, and those are the small list of specifications that are part of the core profile. All right, took care of that. All right, so what's new? All right, so first of all, we had the timeline here. We had the first milestone release, well, first 3, as you can see there, December, March, and April. I think for all intents and purposes, the 4th milestone release is ready, but there's this whole situation where they can't do the milestone until the specs that are part of milestone 4 have their artifacts up on Maven Central. So, so 3 is definitely out there for you to use. And then the final release is scheduled for either later this month or early next month. After, there are 2 specs that are remaining that are getting voted on right now this week to finish their reviews. So, 14 out of the 16 are done. And so I expect that to be released soon. And then they have to go through the voting on each of the different platforms or the profiles. All right, so what else is new? New specifications. Jakarta data, as I mentioned. And what the heck is this micro profile JWT bridge? Yeah, what is that thing? So, so this is something new. We're going to cover that in a minute. Anybody familiar with the old managed bean annotation? That was quite useful. Yes. Yeah, it was actually CDI took its place there. So, but yeah, so that's basically it was deprecated, and then now it's being taken out. Also, references to Security Manager have been removed. Security Manager was deprecated in JDK 17. It's still in there now. It has not been removed yet. Like at some point it will be. All right, CDI Lite. This has always been something that confused me. I think I finally cut it down. It basically has to do with this separation that they have from CDI. This thing working? No, it's not working, sorry. But as you can see there, they separated things out in the context and dependency injection. That's CDI. There's some optional features. Some of these, like Jakarta SOAP with attachments, XML web services, XML binding, they haven't been updated in a while. So there's a whole thing about when you implement a specification, it's requirement to implement some of those things, but there are some optional features that do not have to be implemented. Jakarta validation, if some of you may remember, it was called Jakarta Bean validation. They've shortened the name. It supports records now. Jakarta persistence, same thing with records. And Jakarta concurrency, as you can imagine, now supports virtual threads. All right, RESTful Web Services has improved integration with Jakarta CDI and Jakarta concurrency. And then Jakarta Security, which is the other spec that's being voted on this week, has some additional APIs for different authentication mechanisms, and including the use of interceptors. And then microprofile JWT and Jakarta Security. And then this is that relationship, which we'll get into in a little bit. All right. Okay, so these are the specs here. You see the asterisk next to Jakarta Faces, which used to be called Jakarta Server Faces. They shortened that name. Was supposed to be a 5.0, major release, but I think the spec folks decided that there wasn't enough really to update, so they went from a 4.0 to a 4.1. So that's the only, and then the rest of those are right there. So, all right. All right, there's Rodney again. So, any questions? As you've learned, I tend to talk a little fast, so I try to slow myself down. So, all right.
Fast and a lot.
And a lot, yes. So we're going to highlight some of the stuff in Payara, like Payara Server, Payara Micro, and then Payara Cloud. All right, here's this JWT bridge. Now, there's a micro profile JWT, right, for JSON Web Tokens. But there was this whole idea of for lack of a better word of saying it, it seemed as if some of the Jakarta, on the Jakarta side, wanted to harvest specs from the micro profile side. All right, maybe that's a wrong or too strong of a characterization, but that's that's how I felt. And there's a micro profile config which really works exceptionally well, and then there's a Jakarta config. But I ultimately found out why they did that. So, but anyway, so last summer, I guess a year ago, I got myself at least to attend some of these meetings to create this new specification. All right. And it's a collaboration between the two working groups, as I just mentioned. And your Jakarta security apps can build upon the microprofile JWT spec to provide seamless integrations. And because of this, it eliminates duplication of effort and circular dependencies. Now, this is still a work in progress. And I checked today, and on the GitHub repository, it hasn't been updated in a few months. So I'm not quite sure where all that stands. It was decided to put this in the microprofile set of specifications, and will be a new standalone specification. I'll get that in a minute. So you can see the cartoon and how that relationship works. All right, so microprofile, you can see the core specs on the left. All right, the standalone specs on the right, yeah, they're there for you to use, but they felt as if, not be part of the core. All right, microprofile has a nice rich history. I have a presentation on that. So, but yeah, it's got a lot of great specifications, especially for microservices and for things like observability. So you can see there's a metrics, fault tolerance, and health. So it's very nice set of specs. All right, so for this first demo is basically showing how I think this is going to look. It's you guys see that? How does that look on the screen there? Because
You want to move that widget over? Can you see it?
Yeah.
Move the.
yeah, because my whole resolution changes as soon as I hook up to the.
Come around here and see what we've got. Oh yeah, you want to move this out of the way?
What's that? Oh, that thing. Yeah.
Just grab it and.
I don't want to hit the stop share button.
Oh, here, wait.
Yeah. There's a way to get rid of it, isn't there?
Oh, I'm going to get rid of it.
Thank you. That's why you get paid the big bucks.
Yeah, right. I think that's it. There we go.
Okay, good. Thank you.
Right.
All right, good. Good. See if we can make this somewhat bigger here. All right. So this is a GitHub repo I have with some of the specs, and this is sort of my attempt to see what this is going to look like. There is a new annotation known as, the nice short title of JWT Authentication Mechanism Definition. Say that 10 times real fast, right? Yeah. So you can see all the different things in this annotation. It's quite a hefty list of parameters. All right. So it involves things like the keys and all that good stuff. So what I think, and I had this working before I decided to mess with it, so that's what I get for doing that. I think it's on here. Nope, that's not it. It's here. Okay. So if all right, so you see. Oh no, I had that. Oh, I know, I did that intentionally. Yeah. So here it is. Here it's commented out. So I have here the public key from the application, the location, the algorithm, all that stuff, and that surrounds a method known as echo input. All right, and then when you run this normally, when you pass the authentication part, then you get login successful and input equals and all that other good stuff. So so that I believe is the intent of how we're going to use this. So I think is instead of passing in the entire JWT token, you can just annotate it with that. So that's what I think the intent is, to be determined as they put this together. Because as I said, it's a big work in progress. All right, so more to come on that. Okay. All right, Jakarta data, and this is a new API or a new spec that provides an API, easy access to database technologies. And you can kind of think of this as a overall specification that covers Jakarta NoSQL and Jakarta persistence. And we've had some new committers that really, over the past 6-7 months, really have put a lot into this. And you can see, well, as I'll show in a minute, we have a new query language for that. But the idea is everything's on a repository interface. And the framework will implement that. All right, so the current version is 1.01. There was a minor release just a few days ago. And the implementation is Open Liberty, who's really supported this, with all of their releases of Open Liberty over the past almost a year, maybe not quite. And then Hibernate ORM is also an implementation of this. All right, so what's new in that? We got support for CDI extensions, a new basic repository interface, new methods, insert and update, and then inside the CRUD repository interface, and then new annotations, insert, update, delete, and save that you can use in your application. So a lot of this has changed. The whole pageable stuff has changed over the past few months as well. So that's the beauty of open source and getting things right. There's a Jakarta data query language. This is new, and then you can use this inside a query annotation to specify semantics of query methods, right? And it's a subset of the Jakarta persistence.
Excuse me,
Yes.
one question. What's the difference between save, insert, and update? Save. Why we need save method if we already have insert and update?
So I'm sorry.
I thought we can. We have save, insert, and update. Why do we need save?
The save annotation?
Yes.
Oh, that's a good question. I have not experimented with that. Okay, I'll be honest with you. I'll try to get an answer for you though, if you give me your email. All right, I promise. Okay, but thank you for that though. Yeah. I know I've tried to use them a little bit, but I think versioning, sort of, I ran into roadblocks because of that. So, but yeah. Okay. So quick demo. What time you want me to finish, Mike?
15.
Oh, okay. All right. I'll just run this, and again, you can download it. So I already have everything running. Okay. All right. So I'll open up. I'll have this ready already. Look at that. No. Somehow separated that. Okay, so I'm going to demonstrate Payara Micro. The beauty of Payara Micro, it's a jar file, and you can just, you can pass in the WAR file, and then it'll run right after that. So we've compiled successfully, and now Payara Micro is running. Okay, and then upon successful launch of Payara Micro, you'll see all the endpoints that are listed here. If it did not work, then you would not get these endpoints. So what we can do here is then go to our browser, which is somewhere around here. That's not it. Okay. All right. Okay, so you can see I have a launch page, and then I go to the main application, and that's cute. But the best thing is, this is a beer application too, by the way. As Barry well knows, I'm a big craft beer enthusiast. So you can see the list of beers here, all right? And then there's a list of brewers as well. And you can look upon this if you clone, maybe it's brewer. Oh, there we go. So I have a set of brewers. This is a MongoDB database, so it's no SQL. And so I created the two collections as if I was trying to do a relational, right? That's just kind of came from the relational world, But anyway, then you would use the curl command to add a beer or a brewer and so on. So let's see. Let's continue. All right, Jakarta security. It's a standard for creating secure Jakarta EE applications in modern application paradigms. And I believe this works with authentication and authorization. But it's a nice little tool. I have an application on here that you can try. So right now it's milestone 2 of version 4 that's released. That should change over the next few days. And then you can see the compatible implementations right here, Eclipse Soteria. So, okay, so what's new is multiple authentication mechanisms. And then, so it's ones that previously weren't supported in the past. And then the interoperability with micro profile JWT authentication spec. The roles allowed annotation is part of Jakarta annotations, but there will be a separately defined roles allowed in this spec, I think, to support interceptors. And then also references to security manager have also been removed. And then we'll skip the live demo. Servlet, I mean, those of you who've been around Java EE a long time, right, knows what a servlet is. That this has been, around, quite some time. And then 6.1 will be the new version, and you can see the compatible implementations. And what's new? Control of status code. So there's new ones that I never knew existed. So there's like 301, 302, and all these other codes similar to what we all know all the time, 200, 400, and all that other good stuff. So you can use those, and you would use the set status and get status in order to define that in the HTTP servlet response class. All right. So there's things with query string attributes, and so on, and references again to security managers. That's a pretty much a common theme there. All right. All right. Let's see. We have time for. We can. Yeah. Maybe we won't. So maybe we'll wrap it up. So I do have a user guide that's on Payara that describes all this. Of course, if I was smart, I would have put in the URL in here, so I'll have to do that. But I wanted to say, if you want to get involved, contribute to open source. So many good things happen when you're part of this community and you help out. So Tanya Obradovic, who's the Jakarta EE program manager at the Eclipse Foundation, she had this great thing called SEED. So share, embrace, engage, and develop. And then many of acknowledgments here: Steve Milic, of course, Ivar Grimstad from the Eclipse Foundation. Some of you may know him. Adam Yoho was helped me out with some JWT stuff. And then Sergey, he is I think the lead spec on the microprofile JWT bridge. Otavio Santana, he's the lead spec on Jakarta NoSQL and Jakarta Data. Max is also a committer on the same specifications. And Arjan Times, he and I got together a lot over at DevNexus 2 months ago, and we're looking at the examples and trying to fix various things. Luis Neto, same thing, Java software engineer at Payara. And David Blevins, CEO at Tommy Tribe. Arjan is the one responsible for the Jakarta security specification. This is my contact info and everything else. You can go back to my Twitter account now, or whatever it's called these days, and I've eliminated all political rants on Twitter over the past year because I was wasting my time and getting aggravated for nothing. All right, so I just leave it alone now. Right? And then you got in my portfolio endpoint on my website, you can get the slides for this, and also the repository for the examples. I have I don't know, a good handful of examples, and then not all of them, but a few, some that are not even updated because I found them interesting. But in any event, thank you. It's time for one of those. Sorry, that was kind of short, but, you know.
Thanks, Mike. Anybody have any questions? Questions?
Everybody wants to go home, I think.
Okay, if there are no questions, we can do the raffles.
Ah. So I'll talk to you at the end. Yeah.
I guess we can say goodbye to our people on the internet. See you next time.